Department would like to welcome you all for today's webinar on career opportunities in chemical engineering, a multidimensional career. I would like to tell about our D.Y. Patil International University. D.Y. Patil International University, Akurdi, Pune, has become operational as a state private university and has rolled out with a fundamental mission of covering a remarkable milestone in the history of higher education in India. It further aims to convert itself into a private university of a global value by developing socially relevant and contemporary outcome-based program carrying out inter and interdisciplinary research in thrust areas, enhancing the scope of collaboration for research and boosting faculty and student exchange programs worldwide. Also, by its acute focus on empowerment through education and academic excellence, it aspires to provide an inspirational and experiential learning environment for its stakeholders, and it also keenly responsive towards serving the prerequisites of industry and society by embedding internationalization, employability, and value remunerated in all its programs. Department of Chemical Engineering is under School of Engineering Management and Research. The chemical engineering program at DYP-IU SEMR is distinguished by the integration of latest technologies such as artificial intelligence, data science, process simulation, design thinking, and other into its curriculum. Students are exposed to the transformative capacity of AI in chemical engineering applications through its integration. By enrolling the chemical engineering course, learners develop the ability uh, to effectively employ artificial intelligence tools to resolve intricate problems, analyze data, and optimize processes. By linking conventional engineering principles with emerging technologies, this progressive methodology guarantees that the graduates are adequately prepared to confront present day obstacles within the field. The department have active memorandum of understanding, that is MOUs, with industries of national and international repute. The industries like Rashtriya Chemicals and Fertilizers, Quadragen, and so on. Through these MOUs, the MOUs will cater about upskilling the DYPI students as per the industry standards. Graduates of DYPIU will therefore in an exceptional position to thrive in a swiftly changing professional environment, having acquired a comprehensive understanding of different innovations and chemical engineering fundamentals. In addition to teaching students the principles of chemical engineering, the program curriculum is designed to foster problem solving skills while concurrently imparting the knowledge of chemical engineering students. Dear students and chemical engineering aspirants, today we have organized this particular webinar for you all to listen to the industry experts about the chemical engineering curriculum, its opportunities, and lifelong careers in the field of chemical and allied industries. Now, I request Dr. Utkarsh Maheshwari sir to play the audiovisual clip of 2 minutes, which emphasize about the facilities of chemical engineering department at D.Y. Patil International University, Akurdi, Pune. Please play the clip, sir.
Okay. So this was a small clip what is giving the emphasis on what the Department of Chemical Engineering features at UR Patil International University. Now let's come forward to have to hear with our guest speaker. So to introduce my guest speaker, let me introduce him. The speaker of the day, Mr. Dhaval Saxena. He is a graduate in chemical engineering from Mumbai University and has been in industry for the last 20 years. He is having an expertise in the field of graphite, polymer, and exotic material equipment manufacturing. He is a Lean Six Sigma Black Belt certified. He was ISCSC NOCEL awardee for design and development in industry. He is also a Jeevan Raksha Padak Guarantee awardee. He is an active chemical engineer involved in various activities at national level. He is a fellow member of Indian Institute of Chemical Engineers and Indian Chemical Society. He is presently the group's Chief Executive Officer (CEO) and the Chief Technical Officer (CTO) of Bhumistha Infra Services, Graphite Power Buildings (CPI), based in Mumbai. He is also presently serving as a National Council member of Indian Institute of Chemical Engineers and Registrar of the Institute. He is also the Honorary Regional Secretary of ISCHC Mumbai Regional Center, one of the most vibrant centers of ISCHC. He is also Confederation of Indian Industry, that is CII, National Corrosion Management Committee member. He is a member of Bureau of Indian Standards, NED 17. He was former executive. He was one of the youngest National Council members of ISCHC elected in 2014. So this is some basics about Dhaval Saxena sir. Now I will request Dhaval Saxena sir to please take over. Sir, you can share everything.
Thank you, Dr. Utkarsh Maheshwari, and it's glad to be here. I thank the entire department, and of course, since Dr. Utkarsh Maheshwari is also a National Council member and controller of examinations at IICH, so on that platform we met and we thought, yeah, we are doing many programs on industry institute interactions. So this is one of it, and I found it very wise of him to start at this level, the interactions with the students, that why chemical engineering is required, or what are the career opportunities of chemical engineers.
Dhaval sir, you can share your screen.
Yeah, I'm sharing it. Yeah, my screen is
You can make it first.
it's visible. My screen is visible.
Yeah. So it's, you can make it presentation mode.
Yeah, this yeah. The presentation is visible, or
No, it's the original slide. So you have to just reshare that.
the slides are visible, not the slide showing.
Yeah.
Stop sharing again. Is it
Yes.
visible?
Yes, it's visible now.
So, okay. So, a warm welcome to all, and thank you for inviting me over here. About me
Double sir,
already.
just a small request. Can you have a
Yeah.
little loud voice? Yeah,
Okay.
yeah,
Uh,
now it's
Fine.
fine.
Now am I audible? Yeah. So, uh, a warm welcome to all, and thanks for inviting me over here. So, about me, already Professor Utkarsh Maheshwari has given a very brief introduction. And what about this lecture? We would like to stick with it and try to complete it in say half an hour to 45 minutes. Uh, so I'll be focusing on the career opportunities in chemical engineering, multidimensional career. Uh, what about chemical engineering? And so we'll just start up with the basics like why engineering, why chemical engineering, what is chemical engineering, and we'll be covering with those topics. Yeah. So just a brief about okay, I'm the CEO of Bhumistha Infra Services Group, and we have
Double sir, you are muted.
hello.
Yes,
Yeah, am I audible now?
yes, sir.
Yeah, yeah. So I was just checking the slide. Yeah. So we have like as Utkar just mentioned that we deal with various MOCs. So we have approximately 4 to 5 units tackling tackling this all chemical industry systems and equipments. So, of course, career in chemical engineering. Let us just start. So, I have presented the first slide with Dr. G.D. Yadav, Padma Shri. He's a well-known personality, and he says that God is a chemical engineer. I believe all the students over here can just Google it. How what about his lecture and why God is a chemical engineer? What is there? But he also mentions that all chemical engineers are not God. So uh, it's certain that yes, how he defines chemical engineering in his own way. That when you start in the morning, you have the material, the systems going around, and are all part of chemical engineering. The toothbrush, the belts, the textile you wear, the clothes you wear, the you take bath. So everything I need not explain is a part of product of chemical engineering. So just about the highlight of the Indian chemical sector, since we are here to show you that what chemical industry does and what is it all about. Indian chemical sector is a very crucial component for the country, and certainly it has been proven during the COVID times as well that the chemical industry innovations, research, and productivity in terms of building drugs, manufacturing, even agro. So all these things were tackled in a beautiful way to make our country self-sufficient in terms of vaccinations or in terms of handling the situation as compared to the other countries. There are always lapses and lags, but still, if you compare with the other countries, we were at a much better level. And the Indian sectors, if we talk about the chemical industry, the total GDP it contributes around 1.4%, and to the GVA it almost contributes to 9%. So that is one thing that gross value addition means the products which are being formed are value added. Like when you make a product, you take the raw material, you turn out into a product, finished product, which is being given to buyers, other manufacturers, or to the consumers. So it becomes a value addition for the manufacturer, and that is what it means. The more the value addition is done, the more is the growth of the country. That is what is more important. And the industries those are hiring chemical engineers or chemical manufacturing like production, polymers, plastics, petroleum, pharmaceuticals, food, beverages, energy, environmental management, biotechnologies, of course, material science, electronics, semiconductors, aerospace, and aeronautical industries are also certainly. So basically, chemical engineering is universal engineering, and a person who goes for chemical engineering is certainly has to have a knowledge of a complete package of of the total sustainability package we say. Although chemical industries were in question mark earlier for certain thing, but uh, what we are doing now, or what is the target of the government, or what is the global scenario right now is focused on is to make chemical engineering as good as the Mother Earth, the nature, the atmospheric conditions. Like you see the total eco cycle which is being conducted. I think you must have studied during your school days that how it works, like um, from the trees to the animals, and then the decay part, everything. So it becomes a totally sustainable and green environment. So that is what is the focus of chemical engineers, and that is why it is required. Chemical engineers are required for the society and specifically for the entire globe. That if we are not coming up to make this land or this world more livable, then who else would be? So that's why chemical engineering is necessity and to be taken. And the broad classification, just for basic understanding, I have just mentioned over here that there are four classifications. As such, primary industries is the one which extracts natural resources, and like using the natural resources in terms of like mining, etc., and agriculture, fishing. So all these things, if you talk about the primary industries, chemical engineers play a very important role. Whether it's an extraction process, whether it is preserving, whether it is increasing the yield, so it plays a very important role. Then the secondary industries is like utilizing those raw materials which are extracted and making further products, like when we talk about certain medicines or drugs or even textiles. So that is like the raw material is taken and then converted into a valuable product for the society. And then comes the tertiary, where the industry, whatever is being manufactured, has to be distributed wisely, and we need to have education for the people, what is required, why it is required, and for the public health, etc. And then comes the service and support. That is one industry. I mentioned it at the last, but it is the one industry which is the the industry which came into existence when people realized that it is required at all levels. The service and support is the major you know industry which and that also needs chemical engineers, because running any plant or any production or even explaining anything or educating people, you need to have the background or the knowledge for this production as a chemical engineer. So of course, and this is just a broad sectors wise, like core and non-core. Just we have tried to identify. So in core chemical industry, we would say like refining and fertilizer, agrochemicals, chemicals, pharmaceuticals, API. Then we have EPC and manufacturing, and various big names. I would say like Reliance, even Adani, BPCL, SPCL, IOCL, RCF, uh, UPL, Coromandel, DCM Shriram, Dr. Reddy's, Hetero Drugs, like Remdesivir was manufactured by Hetero Drugs, which was in high demand during COVID. At the same time, we have government organizations like DAE, where heavy waters and is manufactured, and India became self-dependent on producing heavy water in-house with the help of DAE. About DRDO, ISRO, I believe all are aware the current standing in space technology about India. Similarly, EPC and manufacturing companies like L&T, Tata, Jacobs, Toyo, and EIL, and many such companies are there in India who need the chemical engineers basically to run like construction of bridges, cement manufacturing. All these things are covered under EPC and manufacturing of equipments. Like Tata Projects is one company which executes projects from start to end for refineries. Similarly, Jacobs, Toyo, L&T. So these are like the companies which are building the nation basically. The infrastructure available even for an IT tower to make a IT mobile tower for networks, you need the basic raw material has to be produced by a chemical engineer to make it there. And there are then various other sectors like finance, banking, IT, AI, data analytics, and entrepreneurship startups, where we encourage entrepreneurship and startups so that people come forward to build up nation. The main pillars of chemical engineering are like we say that how any particular thing is done. This is actually when we are talking about chemical engineering, we talk about we can give live examples of your day-to-day lives actually. Like there is always a question of how. If you go to your kitchen, if you go to anywhere, like there is heat transfer operations, mass transfer operations. The geyser that is being used at your bathrooms are certainly part of heat transfer, and like how far it is to be. Then the next question comes is how far and the thermodynamics behind it, that how it is being done. We talk about solar panels and things. So you need to have a study and how fast is the kinetics, the kinetic part, like to study the total kinetics, material understanding, what is the material, and stoichiometry, instrumentation and control. When we say instrumentation and control, of course, if you just visualize your house itself, you have so many instruments in and around you, which are required to for the application and use of the products that you are having in your okay. So coming to the industry expectation from graduate engineers, since I believe all over here are upcoming, I think ready to join engineering or which field of engineering have completed their 12th or even younger maybe. So when we pass out from any college, we are really confused like what exactly we are supposed to do. What is like whether we should go for this, whether we should go for that, whether we should go for banking, etc. So there are two things which needs to be taken care. One is my your own interest and skills, and set that what can be done. And second is the need of the society and the industry. So when we say need of the society, it becomes a very broader, you know, saying that the society needs this, but then finally the industry is the one catering the society. So when we say you are supposed to select as per the industrial expectations that where we are going to go. Suppose if you happen to go for like any course, you need to know the syllabus of it. So similarly, over here, when you are supposed to get into any industry, you need to know the expectations of that industry. That what are the expectations? What is my syllabus? What I'm going to study? Like you all got admission at very good colleges. So basically, once you know the syllabus, you able to understand well that what I am supposed to focus on. So right now, the entire education system is focused on the industrial requirements for that purpose because we are generating engineers, but we have to ensure that the industry expectations are met. And as just I explained that when we are at a premature stage, what is to be done. So this slide just represents that people say that we go for engineering, but this is the hot cake. You have good salaries packages over here, and the IT or these kind of sectors, and the person is really confused whether he has to be a leader, he has to be a follower, or he has to go for B or not B. So these all questions are but obvious, and how to address them is very important. Like you see role models in front of you, that what is exactly required. Of course, finance is always important, but not like I give many times example of doctors and lawyers. We all know that doctors are. It's not easy to start earning as a doctor itself. You need to study for a long period after completing all your basic things. Then you start practicing, and that is how you land up in earning. But the thing is, no doctor is you can say all are wealthy. So it doesn't matter when you started. It always matters is what is the culture of the profession, like lawyers or CA. So just we have jotted down few points. What are the basic industry expectations from academia? It is the exposure to real life. We expect the academia to teach the students in terms of exposing them to the real life problems. Overall character development, it is not just, as I just mentioned, it is not about the education alone, it is about the overall development of a personality. When he comes out from any institute, he not only represents himself, but he represents the institute as well. People will always ask you that you belong to which institute or you belong to which university. So when when you show manners, etiquettes, and professionalism, then certainly the HR person sitting at the industry, he says that yeah, this is a well cultured person. And there are many things like with the freshers which industry is still struggling, but after all these industry institute interactions, we are sure we'll be able to develop more better culture and things. Then industry institute interface, interactions, course content, flexibility of approach. A person, whoever is coming out, when you talk about flexibility, many times people flow into a certain regime that I've been an engineer, and what am I supposed to do actually? Uh, should I be on the floor or should I be anywhere? See, when you come for any education, education is required for doing anything. But the thing is, you need to have flexibility in terms of everything, because when you're becoming an engineer, you are going to cater the society and production and things. So you cannot say when running a plant that I don't know this, I don't know that, or I cannot deal with the commercial part, because commercial feasibility is the first thing, and then of course the pedagogy, as I just mentioned, the delivery part, the application of whatever is being studied is very important. How you deliver it, and the solid theoretical knowledge means, of course, many times people say that theoretical knowledge is of no use to the industry. When you go into the industry, it is having no use, but it's very untrue. It is the only thing is you need to connect with your theory and the practical part. There are some basic things, of course. There are some assumptions being made when you go for theory, and as you change your constants, you get the practical things. But 80% if you are able to connect with your theoretical part, you are 100% sure to find the solutions on floor. So these are the few things which are expected, and of course, what matters most. This is the major question that we are dealing with: salary or learning. And nowadays, we just see that people, the necessity. It says it's a revolution, because today people are not struggling for roti, kapda, and makan. They already have the necessities. So what is to be done now? Still, if you are going for everybody wants to earn, but after at the end of the day, when you say uh, without learning, they cannot be earning. That, that is very, very true. Either you learn through the books or you be in the field and learn yourself. That's it. So, just a typical case that I have showed over here. There are two cases, like a person initially joins a very good company with a package, and then he has his own things, and he enjoys certain things. He has nothing to worry about, the work, and he is like, in a comfortable, decent salary, and work-life balance things are going on. Whereas the person B who is struggling for a job, he starts pretty low salary, but then he is unable to join a very big company where from the day one you are at a balanced things. But the thing is, he is on a hectic with there is a too much work. I am being asked to do many multitasking work in the industry, and all these things happen. Like when we are talking about chemical industry, you happen to be there, like I'm going to go on the shop floor and these things. But what exactly happens is when you are struggling and you are working hard and you are given more and more tasks and various type of tasks, like from projects, production, and things, you happen to learn more, and that is what happens at the later end, that one has shaped his life in a way, but and both are like trying to uh, do their best in their work, but still uh, uh, after a few years, when A and B, they both are trying to get a good salary with excellent branding, they start a job search, and what happens is Mr. A, who has a balanced life, is having a specific knowledge of a particular field or a particular work, but the person who has struggled more and be on the the shop floor or learn from there is a versatile person, and suddenly when he addresses the people at the interview, he happens to show a versatility and flexibility much more than a specific person, and then he lands up in a particular a good package, and then he is focused to go for like projects or production or like certain things. So basically, what we are trying to say over here, uh, do not worry about your earnings at the initial stage. It is the learning which is going to earn you for your entire life. So in chemical industry, when you are coming, you may feel that the initial salaries are not high, but at the same time, when you just figure out the things and you go in the right flow, and you will certainly land up in at big positions and big things. And I must say that we have a live example of Reliance, Mr. Mukesh Ambani. He is a chemical engineer from ICT, so which is self-explanatory. Just to explain you about chemical engineer, what is chemical engineering all about? There's a we say that people feel that chemical engineering is all about going for the chemical labs and things. No, it's not so. Chemistry is just part of chemical engineering, but chemical engineering, when we say, it's to build up a plant, like from lab to production level and into a high scale level. A chemist may basically produce a molecule or a drug or something good, innovative in research, but finally, say crocin or paracetamol, what we say, was invented, and but it is of no use unless and until it is affordable by the common person. So the role of a chemical engineer is to basically scale it up, bring the cost down, and make it available for the society, so that it is really helpful for the invention is really helpful for the society. And at the same time, when he goes through this process, he has to deal with many things like building infrastructures. Uh, of course, a chemical plant, you can imagine what all is required. So you need civil, you need electrical, you need the mechanical parts, you need the equipment design parts where the reactions are going to happen. Because at a lab level, it is very easy to have electrical heating and things, but when you go on a plant level, you have to generate, steam for high temperatures, etc. And that is how you heat. And for cooling, you have water being circulated because we cannot emit anything in the atmosphere. And then comes the major part of recoveries, like how to recover your byproducts. We cannot just throw them out. So why not to go for a value addition of those, turning it into a byproduct rather than just calling it a waste. So that is what chemical engineers are all about. And when you do chemical engineering, it's a real responsibility, not just to put your salaries up or something, but along with earning, you are basically the main motive of an engineer is to serve the society, which is being 100% dealt and made sure that it is being done with the help of a chemical engineer. So I've just explained you about chemistry and chemical engineering. Chemical engineering is design, equipment, process, large scale, and manufacturing, etc. And the chemistry is about the basic things in a ground level. Okay, so whenever we have any problem in our life, and that is how we educate our all chemical engineers, because uh, uh, there are many complexities. You talk about any industry, there are always complexities in there. And as a chemical engineer, when you go about, you can master the art of solving problems. So whenever you have a problem, the first thing is you do the analysis, and as you complete your analysis, you find the solution for the problem. And the best part is how to develop that analytical thinking. So when you go for chemical engineering, it's, as I said, that it's a universal engineering. It will certainly make you, and all the parts of your brain will be active, since you are going to deal with so many things and analyze so many things as you go ahead. So analytical thinking is something which is the key for getting into any process, understanding any process, and it can be implemented on any kind of situation, any kind of problems. And there are methodologies to learn how to, basically to your technical skills to be guided well or to be managed well to get the necessary output. And Lean Six Sigma is one of its methodology, which is again very popular not only in chemical industry but at various automobile industries, etc. And of course, automobile. When I say again, chemical engineers have a huge role to play over there itself. But Lean Six Sigma is something which, as it is mentioned, define, measure, analyze, improve, and control. So these are some methodologies which makes you, more develop your more analytical skills, and that is how you can also implement it any part of life, even how to select a branch. So you will define yourself, measure what is the requirement of the society, analyze like what is the requirement of the globe that I'm supposed to do, and then we improve upon, and then we start up with the solutions. Okay, this is required. So being a chemical engineer is the most important need of the day today, because we need more and more chemical engineers. And this is IICG National Institute Training Industrial Training Program. Now things have been upgraded to a next level. When a chemical engineer passes out, we ensure that he is being industrially tuned, and there is a good interaction, between the industry and institute, and they are trained well to be ready to be employable, ready to be acceptable in the industry. And that is the whole scenario why these kind of sessions are being done. to make the engineers more and more aware and more industrially ready. So it was just it's just an initiative, and likewise there are many more initiatives available. Like at IIT, we are running a program. Being a chemical engineer, you have that leverage. That like if you are, I don't know about other professions much, other like when you compare it with other engineerings. The thing is, suppose we have a platform like IICHE, where programs are being conducted at various institutes. You have the access of IIT Bombay, you have the access of ICT, being a chemical engineer. So uh, such organizations are present at chemical engineering, which will certainly give you a very good hand to not only stick with particular. Of course, you are in a good university, no doubt about it. But then you have a good networking, you have a good overview, and you can even have there are courses going on like process engineering course conducted by IICHE to develop more and more engineers to be industrially ready for designing, project handling, and it is conducted at IIT Bombay. The chairman Sanjay Majani, Professor Sanjay Majani is taking that initiative, and I am the secretary over there. And our entire EC is committed to make sure that the engineers passing out are getting in the right hands. So what I mentioned is like the need of the day is about the green solution, and just to give you an example of any industry, just I selected my industry because that is the best example. We are a manufacturer of graphite equipments and delivering turnkey systems from concept to commissioning and commercialization. What is just I have explained to you that we, as a chemical engineer, this is what is required to start to end, like to understand the problem, to take check the necessities, and accordingly to go ahead with finding the solution and to commercialize the product as well. We received a Green Sustainability Award, and this is Dr. G.D. Yadav. As I have just mentioned, he is an inspiration to not only chemical engineers but to the entire society actually for his work, and he happened to inaugurate our plant. Professor M. M. Sharma, again, he is the Padma Vibhushan and Guru of Sri Mukesh Ambani, who inaugurated our plant. And even he, when you speak, you happen to address him, or you can just Google out some of his speeches to learn why chemical engineering and what is the importance of chemical engineering in today's world. I'll just brief out, there are many things, but I think it would be a premature form for all of you. But handling acids, making products like hydrochloric acid is present in any drug. If you eat any medicine, usually you get, if you just see the labels, you will get IPHCl. So hydrogen fluoride is essential for absorption of any food in your body, and that is why it is being added. And you have antacids after that. So that is making those kind of dry HCl gas, IPHCl drugs is another form which is highly required, and we do all sort of things which usually consultancies are not ready to ensure or take a guarantee that in Lumista we take the initiative to develop uh, any kind of process from lab level to the finished product. So these are some of the glimpses of various equipments being used in the industry, pipings. So as I mentioned, these are plants, dry axial gas generation plants, scrubbing plants. As I mentioned, the gases cannot be, we cannot just throw the gases out. We have to make it into a byproduct or scrub it. So these are various distillation columns. You must have heard about, distilling the products, removal of impurities, getting the product, byproducts, etc. Scrubbing stages, and analytical part, various activities being done, and you can see the equipments what are being manufactured at that scale. So being a chemical engineer, you happen to deal with the actual, not it's an actual thing that you are going to deal with and deliver the physical things, not just the platform. And you can just have a look at the columns. Okay. These are various platforms as I just mentioned. So in chemical engineering, we have this culture, like we say that in medical profession, that we provide a platform to all the youngsters coming up to interact with various industrial stalwarts and delegates. So this is all about it. I hope I have covered most of the things. So anyhow, these are few things which at a later stage you may be needing it. So I'll skip up for now. About the recognitions, just a few recognitions being, and we just started this venture, and because we are chemical engineers, so we were able to crack many things at a very early stage as compared to any other engineer. So this is about our chairman, Shri P. Saxena ji, Professor V.K. Srivastav ji. He is a former BARC scientist at chemical engineering. And this is the award. So thank you all, and thanks for your attention. And, if there are any questions, the forum is free to be asked.
Okay. Thank you. Thank you, Dhawal Saxena sir. Any questions from any of the audience? There's no questions for the audience. So I will request, because we have some questions from some of our in the mail. So I will request Dr. Shailesh Gupta to take that questions.
Yes, sir. Thank you.
Yeah.
Okay, let me take the questions further. There are some questions. So the first question is, how do you see the emerging technologies like AI, machine learning, renewable energy, which are going to impact the field of chemical engineering?
Yeah. Machine learning, AI.
And renewable energy, because that is also related to the chemical engineering field. So it's affecting the chemical engineering field.
See some issues there you want to know about the role of AI in chemical industry?
Yeah, because right now a lot of buzz is there with the AI, that data science, and all those branches. So a
Right.
lot of students are little confused that whether that will be taking up the jobs. So what is your take to make them understand that how AI, machine learning, renewable energy are going to impact the chemical engineering, maybe the job sector?
See, being a chemical engineer, if we just talk about, see, it is the safest brand, first of all, because of the simple fact that you are a universal engineer and you are linked not just with a particular stream. Like when you talk about just learning about AI, just learning about some codes or something, it's a different thing, because codes change, language change, there are upgradations in softwares and things change. But when you talk about being a chemical engineer, of course AI is totally linked with chemical engineering, and we are going ahead to link more and more things, because right now if you go to Reliance any plant, you have totally automated systems. It's a humanless, there is no manpower available, you can say, physically visible at the plant. When I pass through, the Patalganga Reliance plant, people many times ask me whether this plant is working or not. It's only at the night time when the light is there, people feel it's working. So when you talk about AI, it is not only, it is highly required for chemical industry and chemical engineering. Why? Because it all starts with data analytics. When you're talking about AI, first step of AI is to collect the data analytics and to study the data, and that is how the AI model works. And of course, then you have to integrate that data and how to utilize it for generating certain things, or how to use that data. Again, now the second part of AI can come is how operations can be controlled with the help of that. But when you're talking about a chemical engineer, we don't see any, like people many times say there will be scarcity or the jobs will become more difficult. So that won't be the situation in any chemical plant, because of course AI is there, but finally it has to be, people, chemical engineers, or a human brain is required behind it. You cannot just, because there are system bypasses, there may be power failure, there may be many things happening in a plant, and you cannot just say that of course it's an AI control, and you can leave it like that. So chemical engineers can, like, we have instrumentation subjects, we have electronic subjects, and certain subjects are already there in the curriculum, for the simple fact that when I mentioned that you are going to run a plant, means you are going to need everything. So when you talk about AI or anything, chemical engineering, there won't be any effect of, on the contrary, it will be proven much beneficial, and more people may be required to develop more better upgradation in terms of AI, because there are innovation in two parts. One is the lab level, the process optimization level. Even in process optimization, if a plant is built, to go to the next stage to increase the productivity or the scalability, of course you can, you have to go for it, and the new AI setups will be required for it, or the new, the what we call is the control logics for controlling any AI. So I think we are much safe, and we can say that we may be the controlling people in the future.
Okay, thanks for the input. Now, next question is, as we are talking about that there are wide field spectrums are available as an opportunity for a chemical engineer. What do you feel will be more suitable for the girls candidate? Because a lot of time the aspirants are saying, sir, whether chemical engineering is for girls also. So what do you think about that regarding the girls' perspective?
Girls, certainly, of course. See, as far as the new society is concerned, there are uh, people. Few people may feel that there are restrictions, but when we are talking about chemical engineering, it's all about innovations. And innovations, I need not define much, or you just go back to the history, and you will get about the requirement. Like, women has a very important role to over here, in terms of designing, in terms of even collecting the data and optimizing the data. There are two factors in a chemical industry. Of course, in Indian culture, we won't say that we cannot imagine a lady to have a hammer in her hand, because we call it a Durga root. So not like that. But anyhow, the thing is, the current chemical industry is very safe, and if you go to Gujarat, there are plants like Cadila, Glenmark, where you see women power really working. And in my company itself, we have approximately 4 to 5 engineers, where women power. In my factory, we have women working, training well. So we don't see any such kind of a thing that it cannot be. It is just that the way you tackle, because there are a lot of things. It's up to them to decide. Of course, safety and things etc. are there, and that is also well tackled in the industry today. much, I think.
Okay, Mr. Ajay Chaturvedi have raised the hand. Can you unmute
Yes,
and
sir.
wait? Yes, Ajay ji.
Ankur here, actually. So
Alex.
the thing is, Dhawanji, I have one question. We spoke at length about, the skill set which is required and all that. So can you speak, can you elucidate a bit about the attitude which is required on the field? Because, a positive attitude and mindset definitely helps.
Right. The attitude on the field. Right. Uh,
Because, sir,
if,
we have lately seen that, especially with the Gen Z coming into the workforce, there is an attitudinal shift which is happening in the industry. So can you throw some light about that for our young students here?
yeah, right. Actually, see, when we, uh, I give very simple and common examples about such things that you have a house, okay, and at US there is Gen Z, and they are cleaning their own houses. They are, driving their own cars, and they are taking care of their own house. Okay, so when you are working in the industry or working anywhere, especially like chemical industry, it's nothing but it's this place is your house. Okay, so as I just mentioned that this Gen Z is not about earning or roti kapda makan, because everybody today is very financially well stable. But then why it is required? Because of the simple fact that I motivated my team members during COVID that if we are not able to support plants, what is going to happen? We supported Etro drugs for manufacturing remdesivir. So what exactly happened? If we just don't go there, a person in your house will require that drug and the drug is not available. So what are you going to do about that? And when you are in field, if you have the same thinking that yeah, the work that I'm doing is not just for me, it is for my family as well, directly or indirectly, then automatically you will have a hammer in your hand and you can fit anything in the plant uh, uh, to make it workable, because it is not just you with your work, your family and the entire families around the globe are going to get secured. So when you are on the ground, you are basically working because of the global culture, or what you say, the sustainability of the entire human race. It's not just that. So that is one thing which Gen Z certainly sooner or later we have to realize, because if there is fire in your house, you cannot say that it's not my work. When you have fire in your house, you need to learn how the fire extinguisher works, to learn how things work, and that is how you go ahead. So whenever you are there on the field, one thing is about excellence, and one thing is whatever work you do should have your own signature mark that yeah, this work is being done by me and this is for the benefit of things. So if any lags are there, that may fall on my on
Okay.
us. Yeah.
Okay. Another question is, can a chemical engineer work in the IT or a management sector?
Yeah, definitely. A chemical engineer can work in IT, electronics, mechanical, civil. You name the sector, I think he can work. And why it is so? Why it is so? Because as I just explained, as a chemical engineer, we are, uh, you know, we the curriculum, we teach them how to operate a plant or to build a plant, or right from the research to analytics to things. So when you think about any chemical plant, you cannot say I don't know about civil, I don't know about the electronics part. The process is not running as a chemical engineer. People will say that you are supposed to make things right over here. So that part, the curriculum takes care very well, and you definitely land up in learning, uh, the basics of computers, the basic of IT, the electronics part, the civil part, the mechanical part. So all the necessary, and reaction kinetics is just one subject in chemical engineering. So when a person passes out from chemical engineering degree, Infosys can take you or any even biotechnologists can take you, or a food person can take you, or any electronics company. Only thing is you are supposed to decide, or you can go for masters for anything. It's up to you. We have examples of that.
Okay, one last question is like, are chemical engineers are in demand globally?
They are in high demand. They are in highest demand actually. See, there is a what there there is always some saying that there are no jobs available. Engineers are not able to get good jobs. That is a different scenario. But when you talk about the industry, chemical engineers are in highest demand today, because as we say that we are a developing nation, or we have China producing many things. And who is competing with China? India is competing with China. There are many other countries competing with China. And how are we competing? How are we competing in terms of taking care of all the natural resources? When we say oil and gas industry, when we say drugs, when we say vaccines, when we say textiles, when we say food and agro, you talk about any industry, uh, it has to be there. Only thing is, chemical engineers need to realize that I have a farmer's son. If turns out to be a chemical engineer, he can do miracles at his farm. Okay, but the thing is, many times people land up that my father is a farmer, but I am a chemical engineer. Probably I should go to oil and gas only, because that's what I have learned, that chemical engineering is all about oil and gas. No, it's not so. Oil and gas is certainly a very big sector, no doubt about it. But when you talk about all these things, you always find like agro, UPL. When you say a very big company, I mean, people can Google it, the quantum of it. So there is a very high demand. When you talk about AI, when you talk about solar, when you talk about renewable energy, what about the development of material? How you are going to get the material? Of course, it's a chemical engineer who has to come forward developing high-end materials like graphene, or high semiconductors and all. And even you see flexible mobiles today. So how is it possible, flexible mobiles?
Correct.
So that is there. So chemical engineers are certainly in a very high demand.
Okay, that are the questions from my side. Dr. Shailesh, any question from your side? Dr. Shailesh, any question from your side?
No, sir. Keval sir, it was very informative session. You have covered almost all the aspects of chemical engineering, the various fields of chemical engineering. You have discussed about the probable opportunities for students today. Again, you have talked, you have nicely covered about the attitude nowadays students should carry. You have guided all our students as chemical engineering aspirants about the chemical engineering field. So we at DYPIU are very much thankful to you for your valuable session. And if any students are or any aspirants are having any kind of questions related to chemical engineering, related to admission process in DYPIU, you are most welcome to put your queries. Our contact details are highlighted on the screen. You can reach us through website, through email, calls, and so on, so that we will be very happy to help you out. Thank you, sir. Thank you so much.
Yeah, thanks a lot.
Thank
Thanks
you,
for
Dhaval sir.
just one. Actually, our chairman has shared a video actually that about some just a minute. Uh, just a short video is available about graphene actually, which is which may attract students.
Please share that.
Is it audible?
Graphene sort of disappeared. I mean, it was out there and we knew it was cool, but we had a lot of trouble making it all at one time or doing things with it. So time for an update. Let me catch y'all up. Graphene is a one-atom thick lattice of carbon atoms. It's supercapacitive, electrically conductive, biodegradable, 200 times stronger than steel, can take pretty much any shape, and is ultralight. It's been theorized to help clean up nuclear waste, easily filter salt from seawater, could make ridiculous headphones, is biocompatible, meaning you can hook it right up to biological cells, read cyborgs, what else? Right. Help make space elevators a reality, create flexible computers, unbreakable phone screens, and create the base for new supercomputers. Needless to say, the shiz is tight. The problem is, it's kind of really super hard to make in large quantities. It's what supply chain management people would call an issue with scale. Until very recently, graphene could only be made in tiny quantities using very difficult processes. For example, a study from 2015 in Nature Communications detailed the growing, yes, growing of the nanoscale graphene lattice on a copper base. But from that, they only got a sheet of 8 by 13 millimeters. So great, not great. Though admittedly, they say that they could, maybe, scale this up. This stuff is so incredible that everyone is working to try and figure out how to make it. But it's just too expensive to make at large scales outside of the laboratory. Though a new 2017 study in Nature Communications detailed how to make graphene in a single step by heating soybean oil to 800 degrees Celsius on a nickel foil that would cause the carbon to arrange into a single one-atom thick sheet of graphene. Slightly hotter temperatures made the sheets of graphene a little thicker. This method is fast, it works in the open air, most others require a vacuum chamber, and could cut the cost of making graphene tenfold. Though again, they're still not scaling it very well. The largest sheet created thus far was about the size of a credit card. Funnily enough, a physics professor just patented an accidentally discovered high-yield graphene creation system. It's scalable, it's affordable, and like the soybean method, it doesn't use nasty chemicals, which a lot of older methods used. To create this, they literally explode acetylene and oxygen using a spark plug. Acetylene provides the carbon for the graphene to create itself in the heat of that explosion, but they don't come out in nice sheets that you can use to make stuff, rather in chunks. I mean, grams of chunks, but chunks. The yield of other methods is measured in milligrams, so this makes way more, but the problem, because nothing is easy, is the graphene isn't as high quality. So they have to fix that, maybe by getting it out of the explosion chamber sooner, they think. We'll see. At least one group of researchers are looking beyond that to when all these problems with making graphene are worked out and are molding the ultralight material into a fluffy, cobwebby network. Their design, published in Science Advances, details how MIT researchers addressed a problem with graphene. When turning it into shapes, big ones, you lose some of its incredible properties. By looking at the atomic structure, they found part of the magic of graphene is the way the atoms are interconnected, the way they look. By mimicking that atomic design on a macro level, they created this weird shape. That mimicked shape lets graphene keep its amazing properties. We just have to figure out how to use that to construct buildings. It's lighter than a plastic bag, but stronger than steel. Someday, they could grow graphene in or on molds just like this one and use them to build a bridge. Assuming, of course, we can ever make it at all. Look, however you feel about graphene, get out there, become an engineer. Not only do we need people out there figuring out how to design bridges based on carbon atoms, but we need more people blowing stuff up to try and invent the world's strongest material, and that person could be you. Science is the best. Want more information on graphene and to find out how it can charge your cell phone in 5 seconds? Watch this super old video I edited myself in 2013. I know. Those were the days. What do you guys think about super strong ultralight graphene? What would you build? Tell us in the comments. Make sure you subscribe for more D News, and thank you for watching.
Yeah. I
Thank
hope
you, Dhaval sir, for sharing this, because this gives an insight that what an engineer can do, because they are talking about the graphene can be used for such a hard material and can be converted, and that's what the engineers can make, and that's definitely a chemical engineer perspective. We can see, yes, that's an opportunity what the chemical engineers can be able to do.
right, and the applications are so wide that starting from the headphones to the batteries and all.
Correct. So that's what it gives a good perspective to the chemical engineering aspirants that yes, the scope is vast.
Right.
So
thanks.
with this, I will thanks Dhaval sir and the team Humestra for being there and helping us for this webinar. So thank you.
Thanks a lot, Utkarsh and Dr. Shankar. It was a pleasure to have you all and impress you, and looking forward for more interaction sessions.
Sure.
Certainly, we invite you.
Yes, sir.
Thanks a lot.
Sure, sure.
Thank you.
Yes. Thank you, sir. Thank you.
Thank
Thank you,
you.
sir. I request Utkarsh sir to please stop the session.